Hey everyone, so now we're moving on to question 9 in the 2019 B test. This question is actually one of the more fun questions in my opinion because it has a lot of, what's it called, recalling from geometry. The question reads, a light board of length L is hinged to a vertical wall. So that's this guy right here. A solid ball of weight G and radius R is held between the wall and the board by a force F applied perpendicular at the end of the board, this guy right here, shown in the figure below. Both the wall and the board are frictionless. The angle between the board and the wall is 60 degrees. What is the magnitude of F? So what force do you need to apply right here in order for this to be in static equilibrium? So how we begin is we start to try to balance the torque on this guy right here, because this guy obviously there's a torque right here, but there has to be a torque caused by the normal force of this ball. Okay, so our first goal should be try to find the normal force caused by the ball on this length L board. And how we do that is we have to look at the geometry of this shape. So we know that, try to draw my best circle right here. Oh gosh, maybe I could use this thing to help me out. No, come on, that's not doing very well. Oh well. Here's a circle, good enough. And here's this board, and here's this board, and this is 60 degrees. Okay, so let's first, in order to find the normal force right here, we have to first figure out what angle this ball is making right here, because as we obviously the angle right here, the ball has a component going down. So if we try to balance the components of the ball, the forces on the ball, so there's also obviously a force due to gravity, and then there's a force going this way from this wall, so the force of normal right here, and there's also another force of normal right here, right? And this force of normal is actually the same force of normal here because of equal and opposite forces, and that's what we want to find because this is the torque that's actually being applied on this board. Okay, so how we find this again is we have to look at this, we have to figure out what this angle is, and we try to balance the forces. Okay, and how we find what this angle is we have to notice that this board, since it's creating a 60-degree angle right here, if we draw something like this, basically this is just another radius and this is another radius, we're splitting this into 30 degrees, and this has to be a right angle because the fact that it's tangent the circle and the board. So this is a right angle right here, so that means that this is 60 degrees right here. So what this means is this is 30 degrees, right, because these two are 90-degree angles, and that means that this is at 30 degrees as well. Just check to make sure that's right. I think that is right. Okay, so what this means is that the force, okay, so the downward force of gravity, let's just say, calculate right now, it's going to be a solid ball of weight G. Okay, so this is the force of gravity, and that must be equal to the y component of this force of normal, so I'm just call it n. And the y component is the sine, so n over 2, sine of 30 degrees is in 1/2, right? So that means that the normal force is actually equal to 2g. Okay, just make sure that I did that correctly. Yeah. Okay, so now we know this normal force is 2g right here, so now let's try to balance the torques on this board. Okay, so this right here is 2g and this right here is F. So another thing that we can do in this in this geometric diagram we drew is figure out exactly what is this length compared to this length of the entire board. Okay, and how we figure this out is because we know that this is radius r, right? because this is just the radius of the circle, right? So that means that tangent of 30 degrees is equal to radius over this length. I'm gonna call it x, radius over x, okay? And so we can write x is equal to r over tan 30. And what actually is tan 30 degrees? It's gonna be, okay, so that means that this is 1, this is root 3. So it's 1 over root 3. So that means this is just r root 3. Okay. And then, so now let's look at the torques. So if we consider this as the pivot, that means that this torque is 2g times the length, the lever arm, which is r times root 3. And this torque must balance out, so this is the clockwise torque, and it must balance out this counterclockwise torque, which is force big F times the entire length. Okay, so what we get is that the force is equal to 2r root 3. This is tangent at 30 degrees is 1 over root 3. So that means that x, yeah, this is right, 2r root 3. Alright, so my bad, I actually kind of made a mistake right here. This teaches us a lesson to not draw messy diagrams. But this is actually 60 degrees considering this angle right here, not this angle right here. So actually this degree angle here is not 30 degrees. Instead, if we just look at this, if we draw this parallel line right here, we notice that these two lines are parallel, right? So this line and this line are parallel. So that means that if this is 60 degrees, that means that this is also 60 degrees, right? And this is 30 degrees, because this is parallel, okay? And then if we draw the same thing up here, what is this angle? So actually, I think it'll be a lot easier if we just draw another diagram. Okay, so obviously that this angle is, so this is 60 degrees, that means this is also 60 degrees, because these two are parallel and this is like a line that connects them. So the normal force right here, which is going to be perpendicular to this line, is 30 degrees right here, okay? But we have to be careful because this thing, the actual force on here, if we draw this we draw this line right here, we draw this line right here, obviously this forms a 60-degree angle right here, right? Because these two form a right angle. And then since these two, we can like imagine this as like a line connecting them to these two. So then using the geometry stuff that we learned, that means this angle is also 60 degrees. So instead of having 30 degrees right here, this angle should have been 60 degrees. So FG should have been equal to n root 3, 60 degrees sine, yeah, so that's root 3 over 2 instead of just n over 2, okay? So that means n is equal to 2 over root 3g. Okay, and that means that right here, we're multiplying by 2 over root 3. Okay, now this makes a lot more sense. We cancel out, so then we're ended up with 2 over r, okay, 2 over r divided by length times g, and that gives us the right answer, which is B. Alright, that was a bit of a wild ride. Sorry about the little mess ups. Hopefully this all makes sense to you.